Imagine a car engine as a hungry beast. Its appetite? Air. The more air it consumes, the more power it generates. But there's a limit to how much air an engine can naturally take in. That's where forced induction comes in, with superchargers and turbochargers acting as the ultimate force feeders for your engine. These ingenious devices force more air into the engine than it could draw in on its own. This denser air, packed with oxygen, allows for more fuel to be burned, leading to a significant boost in power output. Imagine transforming your everyday sedan into a roaring beast, capable of leaving sports cars in the dust. That's the magic of forced induction. But how do these power-boosting marvels actually work? And what are the key differences between a supercharger and a turbocharger? Let's dive into the mechanical heart of these systems to understand their inner workings. Picture a supercharger as a compact air pump, typically bolted directly to the engine. Imagine a system of gears and belts connecting the engine's crankshaft to the supercharger. As the engine spins, it drives the supercharger's internal mechanism, which compresses the incoming air. At the heart of many superchargers lies a pair of meshing lobes. These lobes, resembling elongated gears, rotate rapidly within a tightly sealed casing. Air is drawn in and trapped between these lobes, squeezed and compressed as it moves towards the engine's intake manifold. The result? A continuous flow of high-pressure air, ready to be mixed with fuel and ignited for a surge of power. Now imagine a device that utilizes the engine's own exhaust gases to generate power. That's the ingenuity of a turbocharger. Picture a snail-shaped housing, containing a turbine wheel connected to a compressor wheel by a shaft. This entire assembly is mounted on the engine's exhaust manifold. As exhaust gases exit the engine, they rush through the turbocharger's turbine, causing it to spin rapidly. This spinning turbine, connected to the compressor wheel, forces air into the engine's intake. Essentially, a turbocharger recycles energy that would otherwise be wasted, transforming it into a source of immense power. Both superchargers and turbochargers operate on the same fundamental principle: compressing air to increase its density before it enters the engine's combustion chamber. By squeezing more air into the cylinders, they allow more fuel to be burned with each cycle. This intensified combustion process translates directly into increased horsepower and torque, giving your car that exhilarating surge of acceleration. Think of it like this. Imagine blowing on a small fire. The force of your breath provides more oxygen, making the flames grow larger and hotter. Similarly, superchargers and turbochargers act as mechanical lungs, force-feeding the engine with air to enhance its power output.